Mole fraction is another way to show concentration. We've done percent by mass and percent by volume, where you look at the amount of the substance for the total, both in grams or in volume units, so liters or milliliters. We've looked at molarity, we've looked at molality, and they both compare the amount of moles to a certain amount of the solution or solvent, either in kilograms or liters, depending on which substance you're looking for. So mole fraction is comparing the amount of moles of one part to the moles of the total solution, and then you get a fraction. If you do the mole fraction for multiple substances, you will have all of them should add up to be 1. So these numbers are going to be small. They'll be less than 1, but not 0. To find mole fraction is illustrated with the symbol of X. Okay, and often they'll put a subscript of what substance you're looking for. So you might see X with a subscript of H2O, and what they're asking you to do is to find the mole fraction of water. And so how you find the mole fraction is you take the moles of the part you're looking for, and you divide by the moles of all the parts. So that would include the part above and the moles of the other parts. So if you have 2 parts, you would have moles of part A, and then also you would add in part B. Alright, so we have a sample problem. It says, what is the mole fraction of 50 grams of NaOH in 250 milliliters of water? So we are trying to find the mole fraction of the NaOH, and we need to know the number of moles of NaOH and divide it by the moles of NaOH plus the moles of water. So we got to do a couple of steps before we can actually solve for the mole fraction. We need to convert our 50 grams of NaOH into moles. So you will take and convert from grams to moles using the molar mass. And the molar mass of NaOH is 40 grams of NaOH. And you would then get 50 divided by 40 will give us 1.25 moles of NaOH. Okay, so that's the first part. We need to take our 250 milliliters of water, and we need to remember that water has a density of 1 gram per 1 milliliter. So we will know that 250 milliliters of water is also 250 grams of water. Then we need to convert that into moles. So 18 grams of water and 1 mole. So 250 divided by the 18 is, I've run out of room, we'll put it here, 13.8 moles of water. Okay, so we will now set up our problem. So 1.25 moles of NaOH, and on the top, and then we're going to divide by all of the moles. So we'll have moles of NaOH, and we'll have the moles of water, and that will give us our mole ratio. So 1.25 and the 13.8 would give me a value of 15.05. So to solve it, we take 1.25 divided by the 15.05, and we get a mole ratio of 0.083, we'll call it 1. And mole fraction has no units because it's a comparison of moles to moles. So you need to make sure that you've labeled it as X nearby. Here's a little bit more challenging problem. This problem is telling us that we have 36% HCl solution, which is a concentrated hydrochloric acid solution, and it wants to know the mole fraction of water. So we are looking to find the mole fraction of water, and we are going to realize that we have 36 grams for every 100 grams of solution, and we have 36 grams of HCl. So if we have 100 grams total and we're subtracting the 36, we would then have 64 grams of water. So we need to convert our grams of HCl and our grams of water both into moles. And I'll do that right here. So grams of HCl. And HCl would have a molar mass of 36 grams per 1 mole. So that's 1 mole. And our 64 grams of water, we would convert into moles using our molar mass of 18. So 64 divided by 18 is 3.55. So to find the mole fraction of the H2O, we have to take the moles of the water divided by the moles of all of the moles. So we would take 3.55 divided by 4.55, and you get a mole fraction of 0.78, and there's no units, and it's just the moles of the water. So if we wanted to find the mole fraction of the HCl, we could take 1 and subtract it from the mole fraction of the HCl, and it would be 0.22.